Morning students, today we are going to discuss two-port network problems with dependent sources. So far we discuss problems with independent sources. Now consider the dependent sources. Right? Today we discuss problems with dependent parameters. Okay. Here this is the given problem. Here the given problem is resistor R1. There are three resistors in this network, R1, R2, R3. This is the voltage source, current controlled voltage source, whose value is 3I2. Current controlled voltage source. This value depends upon the current I2 current 3I2. Similarly, it is a voltage controlled current source. It is a current source whose value depends upon V1. So voltage controlled current source. And R3 is 1 ohm resistor. Here V1, V2, I2, I1. If the problem is find H parameters. This is the figure A. Find H parameters. Once again, here in this problem it consists of voltage controlled current source, current controlled voltage source. This voltage source value depends upon I2 current. This current source value depends upon V1, port 1 voltage. If the problem is find H parameters. Okay, here the procedure is, first of all write down the H parameter basic equations. Okay, already you know it is a hybrid parameters. That means we use open circuit concept as well as short circuit concept. Okay, in case 1, when V2 is equal to 0, V2 is equal to 0 means short circuit. So what are the remaining two parameters, H11 and H21? H11 is equal to V1 by I1. H21 is equal to I2 by V1. Here the ohms are, these are the ohms. Here there is no units. Similarly, case 2, I1 is equal to 0. When I1 is equal to 0, there is an open circuit concept. H12 is equal to V1 by V2, reverse voltage gain. Similarly, H22 is equal to I2 by V2. Here the units are mhos. Now we start to analyze the problem. Okay, this is the given problem and apply the case 1. What is the case 1 here? Case 1 is equal to V2 is equal to 0. When V2 is equal to 0 means short circuit. Draw this one. Here this one is short circuit. V2 is equal to 0. Now what happens means, when this is a short circuit, there is no drop across 1 ohm resistor. Here it is a 1 ohm resistor R3. This is R1, R2, R3. So there is no significance of 1 ohm resistor here. Now there is no drop across 1 ohm resistor. Now figure B can be equivalently drawn as figure C. Okay, simply neglect R3. Okay, short circuit. Now this is the equivalent circuit. Okay. Now here two loops are there. This is the loop 1. This is again loop 2. This is figure C. Now consider the figure C. Consider figure C. Okay. Apply KVL to loop 1. This is the loop 1 and this is loop 2. Apply KVL to the loop 1. Now what happens means, current flowing through 4 ohm resistor is I1 as well as I2. Now here I am writing directly V1 is equal to 3I1 plus 4I1 plus 4I2, and this is a voltage source, current controlled voltage source. So voltage source plus 3I2. Okay. Now simplify this one. 7I1 plus 7I2. V1 is equal to 7I1 plus I2. This is equation 1. Similarly, in loop 2, observe here. In loop 2, it is a current source. It is in entire loop only single current flows here. In loop 2, what is this value is 0.5 V1. In loop 2, current I2 is equal to I2 current is equal to, already given in the problem, I2 is equal to 0.5 V1. Now here 2 in 1. This is in 1. Now V1 is equal to 7I1 plus 7I2. I2 is equal to 0.5 V1. Simplify this one. 7I1 plus 3.5 V1. Here V1. And again take this side. Minus 2.5 V1 is equal to 7I1. From that V1 is equal to 7 by 2.5 I1. So that is equal to V1 is equal to minus 2.8 I1. So this is okay. So this is 1. This is 2. Here 2 in 1. This is 3. Now here from this one, from 3, what is H11 here? H11 is equal to V1 by I1. So H11 is equal to V1 by I1. From this one simply that is equal to minus 2.8 ohms. So that one parameter is H11 is equal to minus 2.8 ohms. Okay. Now again 3 into this is 3. Substitute V1 value in 2. So that I2 is equal to 0.5 V1. What is V1? V1 is equal to minus 2.8 I1. That is equal to minus 1.4 I1. So H21 is equal to I2 by I1, that is equal to minus 1.4. Okay, again we calculated another parameter, minus 1.4. Okay, there is no units. This is the case 1. The once again here it is case 1 is V2 is equal to 0. When V2 is equal to 0 means short circuit concept. V2 is equal to 0. So there is no drop across here R3. There is no significant of R3 resistor. Why? Because it is a short circuit and drop is equal to 0. Then equivalent circuit diagram is, this is equivalent circuit diagram. See. Okay, here 2 loops. Apply KVL to loop 1. Current flowing through 4 ohm resistor is I1 as well as I2 with the same polarities. So 3I1 plus 4I1 plus 4I2 plus 3I2. This is a voltage source 3I2. Then simplify. Then V1 is equal to 7I1 plus 7I2. Similarly, in loop 2, current is equal to 0.5 V1. Then again 2 in 1. Then you will get V1 is equal to relation between V1 and I1 minus 2.8 I1. From that, one H parameter is equal to minus 2.8 ohms. Now again 3 in 2. Then another H parameter is minus 1.4. Okay, consider the case 2. I1 is equal to 0. Okay, when I1 is equal to 0, that is open circuit concept here. Port 1 I1 is equal to 0. The remaining everything is as well. Here one important consideration is this is I2 current. I2 current divided into I2 dash as well as I2 double dash. Right? Now this is the equivalent figure after applying the open circuit. Now apply KCL at node B. Here this is the node B. Apply KCL. What is I2 is equal to I2 dash plus I2 double dash. Already given current. This is the current source. Current source. Voltage controlled current source. Current source value is 0.5 V1. Here what is I2 double dash? Voltage by resistor. I is equal to V by R. Here this is the voltage V2. V2 by R is equal to 1 ohm. So V2. So I2 is equal to 0.5 V1 plus V2. This is equation 5. Now here important concept is I1 is equal to 0. In loop 1, this is loop 1. In loop 1, there is no drop across 3 ohm resistor. No drop across 3 ohm resistor. So now what happened? KVL. Apply KVL to loop 1. Then what happened means here it is the voltage at node is V1. Directly V1 is equal to, here the current flowing is, this is the current flowing I2 dash. 4 I2 dash plus, and this is the voltage source, that is equal to 0.5, that is equal to 3 I2. Then again already given I2 dash is equal to I2 dash is equal to 0.5 V1. Then simplify. V1 is equal to 4 into 0.5 V1 plus 3 I2, that is equal to 2 V1 plus 3 I2. This is V1. So come this one, what happens means minus V1 is equal to 3 I2. So this is 6. Okay. Then again 6 in 5. 6 in 5. This is the 6, this is the 5. Then I2 is equal to 0.5, V1 is equal to minus 3 I2 plus V2. Then simplify this one. Minus 1.5 I2 plus V2. This is I2. And again this one, 2.5 I2 is equal to V2. So now from that there is a one more relation, that is H22. Here H22 is equal to I2 by V2. Now H22 is equal to I2 by V2. I2 by V2 is equal to 1 by 2.5. 1 by 2.5, that is equal to 0.4, and units are moles. So this value is equal to 0.4 moles. Okay. Now here the procedure is here current divides. Observe here in figure D, current divides, that is important. I2 current divided into I2 double dash and I2 dash. Apply KCL at B, then you will get equation 5. Then again apply KVL at loop 1. There is no drop across 3 ohm resistor. Directly V1 is equal to 4I2 dash plus 3I2. Then simplify, you will get 6. Then 6 in 5, you will get 1 H parameter, that is equal to 0.4 mhos. H22 is equal to. Now again 5 and 6. Now 5 and 6, this is the 5, this is the 6. Substitute I2. So minus V1 is equal to 3 into I2. I2 is equal to 0.5 V1 plus V2. Then simplify this one. Then 1.5 V1 plus 3 V2 is equal to, this is minus V1, and take this side is equal to minus 2.5 V1 is equal to 3 V2. Then again here another parameter H12. Here one more parameter H12 is equal to V1 by V2, reverse voltage. And this is V1, this is V2, V1 by V2. So 3 by minus 3 by 2.5, that is equal to minus 1.2. So H12 is equal to minus 1.2. So this one is equal to minus 1.2. So finally H matrix is equal to minus 2.8. Here total 4 values. H11 minus 2.8, H12 minus 1.2, H21 minus 1.4, H22 0.4. So like that you can find. Okay, this is the complete solution for given problem. Like that you have to find the H parameters. Now I request all students, once you know the H parameters, you can easily find Z parameters, Y parameters and T parameters. I request all the students, by using H parameter values, H11, all these values, H11, H21, H2, H12, H22, you have to find Z parameters. Already we know the how to express Z parameters in terms of H parameters, Y parameters in terms of H parameters, T parameters in terms of H parameters, right? Observe this like video lecturers and find Z, Y and T parameters.